Hi, I bid to my lecturers and my fellow friends. My name is Muhammad Syamil Afham bin Muhammad Sabri, metric number AF210026. So today I would like to present about our project, and for my part is the introduction. So basically, project focus, evaluate and enhance the acoustic and lighting performance of Day 1 Kuliah C Block G3 UTHM. Importance: acoustic and lighting design directly affect comfort, clarity and energy efficiency in learning environments. And lastly, objective. The first one, assess reverberation time, background noise and lighting levels. Compare finding with MS 1525 and ISO 33821 standards. And the third one is propose practical design improvement using suitable technology. So, scope of work: site data collection and acoustic lighting measurement, analysis using professional tools and software, and lastly, improvement proposal and 3D visualization redesign. So, study area: Dewan Kuliah C DKC UTHM used for lectures and academic sessions. Design guidelines based on international standard for speech intelligibility, lighting uniformity and energy efficiency.
Hello, my name is JB Johnson Bijiku, and I'm going to present the measurement procedure and setup for acoustic performance test and lighting performance test. So the test was conducted at Dewan Kuliah C at UTHM. For acoustic performance test, we need three tools. First one is omnidirectional speaker, sound level meter, and lastly laser distance meter. For lighting tools, we need lux meter and laser distance meter. So the step for sound measurement: firstly, we need to empty the hall, so we made sure the room was empty and quiet. Next, we measure the room. We measure the hall's length, width, and height. Next, we make a grid. We mark 24 spots on the floor evenly. Next, speaker setup. We put the speaker on a stand at each marked spot. For SLM setup, sound level meter setup, we put the sound meter on a stand at two different heights, sitting and standing ear level. Lastly, we record the data. We did this for all the 24 spots, recording sound levels and the echo times. So for light measurement, firstly, we use a lux meter and check all the lights. Next, we divide the hall. We split the hall into front, middle, and back sections. Next, we set the height. We held the lux meter at desk height, which is 1.2 meters, and point it up. Next, we take reading. We measure the light at each spot, making sure nothing blocked the meter. Next, we write it down. We record the light meter, the light level, the time, the light type, and any issues like glare. Lastly, we'll check with the standards. We compare our readings to recommend light levels, which is 300 to 500 lux, to see if changes are needed at the room.
Hi, my name is Siti Noramita Amran, AF210035. So I will continue on acoustic analysis. So basically, before we assessing overall the room acoustic, we will take a look for the background noise level. So for the first one, what we measure is the several position in the hall, so covering frequencies around 63 Hz to up to the 800 Hz. So the result shown that the highest frequency, especially at 63 Hz and 135 Hz, the values around 39.6 and 29.3 decibel respectively. So maybe this is because from the HVAC system of the or structural vibration around surrounding the classroom, and which are more the noise level dropped significantly, mostly falling below 15 decibels, that's a good sign because these are the frequency that directly impact the speech clarity. So basically from this analysis, what can I say, that the space is relatively quiet and acoustically controlled. So the only minor issue is the low frequency intrusion, but it doesn't exceed the acceptable range for the classroom or office like environment. So for the overall background noise level in Dewan Kuliah C is well within acceptable limit for its purpose. Next part is the noise rating or NR evaluation, which is a method used to assess how suitable the background noise levels are for a particular type of space. So it's especially important in place like a classroom where speech clarity is critical. So to perform this evaluation, we measured the sound pressure levels at different frequency from 63 Hz up to the 8000 Hz and compare the result with standard noise NR curves such as NR20, NR30 and so on. So as shown in the graph, the measured noise levels in Dewan Kuliah C stay consistently below the NR30 line, so which means the background noise in the hall is quite enough for teaching, learning and general office. So but there was a slightly increase in low frequency noise, especially around 63 Hz. But it didn't exceed the threshold. So overall, we can conclude that Dewan Kuliah C falls under the NR30 classification, which confirms that the room provides a suitable acoustic environment for its intended purpose. Now we move on to the reverberation time or RT60, which is a measure of how long sound takes to decay by 60 decibels after the source has stopped. So this one of the most important acoustic parameter in the lecture halls because too much reverberation can make speech unclear, while too little can make the room feel dull or unnatural. So in our study, RT60 was measured across multiple frequency and position in the room. We found out that the reverberation time ranged from 0.50 to 0.79 seconds. So for the highest value occurred at low frequency, particularly at 125 Hz, which is quite common due to the lack of low frequency absorbers. However, in the mid frequency range from 500 to 2000 Hz, which is where speech occurs, the RT60 remain between 0.52 and 0.59 seconds. So, this is within the recommended range of 0.4 to 0.6 seconds for the lecture hall, according to ISO and
speech clarity. Our goal are to reduce
and
reverberation,
overall,
improve speech
the
improvement,
reverberation
create
characteristic of the hall support good speech
Secondly, fabric cover panel on the
intelligibility.
rear wall to
So,
control echo.
what I
Next,
can
wood
conclude
diffuser and foam panel on
from
side wall
this
to balance sounds. In addition, bass track in
analysis,
corner for low
both
frequency
the
control.
noise level
Lastly,
and
carpet tile
reverberation
in front area
performance
to
of
absorb
Dewan
footfall
Kuliah
noise.
C are
This material was
largely
selected based
within
on
the
their
acceptable
application
range
condition
for
and suitability
educational
for
use.
educational
And
spaces.
the background
For
noise
lighting, although
levels
the
falls
average
under
brightness
the
was standard, the
NR30,
uniformity ratio was only
indicating a
0.134,
quiet
which is
environment
far
that
below
won't
the required
interfere with
minimum for lighting.
concentration
We
or
propose this
speech
acoustic
clarity.
lighting as
So for the
ready to read
reverberation
and eye
time
sensor
is a
downlight
well
in dim zone.
controlled in the
Next,
most
12
important
under seat
frequency
activity
range
straight
for
for
the
student
speech,
class lighting.
staying
In
within
addition, dimmable
0.5 to
control and motion sensor
0.6
for energy
seconds,
efficiency and
although they
reflective
are
white panel to
slightly
improve light
higher for
distribution.
the
In
RT
conclusion,
values
this
at
improvement
a
will
lower
lead to better
frequency,
acoustic
they
clarity,
don't significantly
lighting
impact
uniformity,
the
energy
clarity of
efficiency, and
spoken words.
enhance learning atmosphere for all users
Because
across
of
the hall.
this,
Thank you.
no major acoustic upgrades are strictly necessary. However, if further improvement is desired, especially for low frequency control, minor enhancements such as bass traps or rear wall treatments could be considered in this Dewan Kuliah C. So overall, this room is the room is performed well acoustically for its function as a lecture space. So that's all from me. We move on to the lighting analysis.
for the lightning analysis, the first one is illuminance level, which is the illuminant type, which is LED panel light. The quantity is 20 units, and the luminous flux per unit is 3,600, and then all the total luminous flux is 72,000. And for the recessed LED downlight, there are 12 units, and the luminous flux per unit is 1,000. For the total is 12,000. So the total for the luminous flux is 84,000. So the lighting system in G3 Dewan Kuliah C UKHM comprises two types, which is luminaire panel light, LED panel light, and the LED round light. So by using this formula, which is luminous flux over to the area, we got 356 lux. So the calculate value of 356 lux falls within the recommended range, which of 300 to 500 lux for the lecture halls as per MS 1525/2019 indicate that the average brightness level is adequate for academic use. For the lighting uniformly, to evaluate the uniformity, illuminance was measured across a 1 meter times 1 meter grid using a lux meter position at standard desk height, which is 1 meter. So a total of 208 points were recorded as shown in the figure. From this, the average and the minimum luminance were determined, which is average luminance is 471.7 lux, and the minimum illuminance E minimum is 63 lux. To find the uniformity ratio, we take the E minimum over to the average. So we got is 0.134. So this is the figure, as you can see here. And the lightning, so the resulting uniformity ratio of 0.134 is significantly below the minimum recommended value, which is 0.7 according to the clause 443 of MS 1525/2019. So it is indicating that the substantial unevenness in lightning distribution. So poor uniformity will result in the discomfort, eye strain, and difficulty in visual tasks, especially in underlight sitting zones. For the energy efficiency analysis, we got the total weightage which is 840 watt. So the energy performance of lighting system in assessed through the lightning power density, which is LPD. We got by using this formula, we got the LPD is 3.56 watt per meter square. So the LPD is well below the MS 1525/2019, which is the limit is 13 to 15. So it demonstrating excellent energy efficiency, mainly attribute to the use of the high efficiency LED luminaries. So summary of the lighting performance, the lighting system in G3 delivers an average illuminance which is 471.7 lux. It's complying with the MS 1525 standards. Furthermore, the system exhibits superior energy performance with a low LPD of 3.56 watt per meter square, which support the sustainability goals and the reduced operating costs. However, the system significantly underperformed in terms of uniformity, with a unit of 0.134, which is below the acceptable threshold with of 0.7. So this inconsistency in light distribution can compromise visual comfort and learning efficiency. So in this table shows the summary of the lighting performance, which is the average luminance is 471.7 lux. So on the MS, the requirement is 300 to 500 lux. So the performance is compliance. For the minimum illuminance is very low. By the uniformity ratio, not compliance because the measure value is 0.134, while the requirement is more than 0.7. For the lighting power, we got the 3.56 watt, while the requirement is between 13 to 15, so it's compliant. So in conclusion, while the system satisfies average brightness and energy efficiency requirement, a major shortcoming lies in its poor uniformity. A revised luminaire layout and additional lighting points are necessary to enhance the spatial consistency and ensure full compliance with national lighting standards.
For the conclusion, acoustic finding. Reverberation time for sensitive values range from 0.52 to 0.79 seconds, close to acceptable range but slightly high at low frequencies. Background noise measured at 29.8 dB, just above the ideal 25 dB limit. Lighting findings, average illuminance 471.7 lux, complying with MS 1525. Uniformity ratio is 0.134, below the recommended, which is 0.7, and energy efficiency excellent with LDP at 3.56 watt per meter square. So the problem identified is the first one, acoustic echo at low frequencies may reduce speech clarity. The second one, poor lighting, uniformity affects visual comfort and student focus. So our recommendation, the first one, install acoustic panels, bass straps and carpet for better sound control. The second one, add LED lights and task lighting, improve layout for better light uniformity. And the final outcome, implementing this improvement will create a more effective, comfortable and sustainable learning environment. Thank you.